Good morning, Professor. My name is Naomi. So, have you ever imagined a world where we could process multi-million dollar transactions, execute complex business agreements, or share confidential medical records without ever needing a bank, a lawyer, or any third-party middleman? Today, we are going to explore the technology that makes this possible. We will be discussing Ethereum and smart contracts, what we often call the architecture of digital trust. Let's start with the first question. What is Ethereum? Most people are only familiar with Bitcoin, but while Bitcoin was created purely to be digital money, Ethereum is designed to be so much more. Introduced by the visionary named Vitalik Buterin in 2015. Ethereum sparked a technological revolution that we will classify as blockchain 2.0. Ethereum is not just a cryptocurrency, it is a globally decentralized peer-to-peer computer network to ensure its foundation is absolutely secure and transparent. Ethereum is built upon four main architectural layers. The first one is the application layer. This is where the programs and applications actually live and operate. The second one is the consensus layer. This is how the global network of computers agree that a transaction is valid and true. The third one is the data layer. This layer secures all the information using advanced cryptography, specifically digital signatures, hashes, and merkle trees. The fourth one is the network layer. This handles the communication between all the computers around the world. In short, Ethereum is a giant, unstoppable global computer. Next one, we talk about what is a smart contract. Now, this massive global computer needs programs to run. This is where the smart contract comes into play. What exactly is a smart contract? The easiest way to understand it is to think of a vending machine. With a vending machine, you put your money in, press a button, and the machine automatically drops your drink. You do not need a human cashier to process the sale. The machine simply executes the rule program inside it. A smart contract does the exact same thing, but in the digital world, in a traditional business model, if you want to buy a horse or sign an agreement, you need a middleman, like an agent, a notary, or a bank, which take a lot of time and cost a lot of money. A smart contract eliminates all of that. It is a small piece of self-executable program code that is deployed directly into the blockchain. It features zero middlemen and automatically enforces the agreed terms between two untrusted parties. Because it is secure and the Ethereum network, this little piece of code is capable of safely managing and transferring millions of dollars in digital assets. So, how does a smart contract actually come to life? The execution cycle consists of four main steps. Step 1 is coding. Just like building a regular app, a developer must write the rules of the contract. They do this using a highly advantageous Turing-complete programming language, most commonly known as Solidity. Step 2 is complication. Because the computer network cannot read human language, the Solidity code is translated or copied into machine language known as EVM bitcode. Step 3 is development. Once translated, the code is permanently stored on the Ethereum blockchain. During this process, the contract is assigned its own unique address so it can be found on the network. Step 4 is execution. To actually use the contract, users send a transaction to that unique address. However, using this global computer is not free. You must pay a computational fee called gas. Once paid, The contract runs safely inside the isolated environment known as EVM or Ethereum Virtual Machine. The next one, we talk about the 3 pillars of smart contracts. Why is this technology considered revolutionary? It is because smart contracts are built on 3 fundamental pillars that traditional computer systems simply do not have. The first pillar is trust minimization. They allow users to communicate and trade in a completely trustless environment. You do not need to know the person on the other side, and you do not need intermediaries because the mathematical code guarantees fairness. The second pillar is global transparency. All the data and rules are stored globally across thousands of computer nodes. This means the rules of the agreement are entirely visible and verifiable by everyone. The third pillar is immutability. This is the most powerful feature. When a smart contract is deployed on the blockchain, its code becomes permanent. It cannot be altered, changed, or deleted by anyone, not even by the person who created it. Next, we talk about the real-world application. Empowered by these 3 pillars, smart contracts allow us to build highly sophisticated decentralized applications or DApps. This technology goes far beyond just cryptocurrency. Here are a few real-world applications across different sectors. The first one is IoT, Internet of Things. Smart contracts can securely connect smart devices. For example, a factory sensor could automatically order and pay for replacement parts the moment it detects a mechanical failure. The second one is healthcare records. Hospitals can create highly secure medical data system. Patients can grant specialists temporary access to their records via a smart contract, knowing their data cannot be manipulated. The third one is commercial services. Business agreements like flight insurance can be fully automated. If your flight is delayed, the smart contract checks the official flight data and instantly transfers the compensation money to your account with no claim form required. The last one is secure data exchange. Global corporations can safely trade sensitive information and digital assets with mathematical security guarantees. Now we talk about the risks, limitations, and the future. However, no technology is perfect. Running this powerful engine for global automation demands rigorous security. Why? This brings us the downside of immutability. This permanent nature is actually a double-edged sword. Developers are human, and humans make mistakes. If a developer deploys a smart contract that contains a bug or vulnerability, that code cannot be easily patched or fixed once it is live on the blockchain. This is extremely dangerous because this contract holds massive financial value. Let's look at the critical failure log from 2023. Due to simple code exploitation, hackers managed to steal a staggering $197 million from Euler Finance and $200 million for the Mixin network. These are disastrous financial losses caused by structural vulnerabilities. So what is the solution? As highlighted in the academic reference of the presentation, researchers are now fighting back by combining blockchain with machine learning and AI. Advantage AI methods are trained to automatically scan and detect vulnerabilities within the smart contract code before it is ever developed to the network. artificial intelligence is becoming our first line of defense to keep this ecosystem safe. So in conclusion, Ethereum provides an incredible decentralized foundation, and smart contracts serve as an ultimate tool to replace middlemen with immutable code. While the technology still faces critical security risks, ongoing innovations like AI detection ensure that blockchain 2.0 remains the most powerful engine for digital trust ever created. So this is the reference that I use in my presentation. There are two references that I use it. This brings me to the end of my project presentation. I hope this video clearly demonstrated the architecture of digital trust, a technical overview of Ethereum and smart contracts. Thank you for your guidance and attention throughout this process, Professor.